all of the trigonometric values given a certain point on the terminal side of an angle theta. So let's first draw a sketch of what this triangle looks like so that we can answer all of the trig values that it's asking for. So negative 5 over 2 would be located as a negative x and a positive y. So that means it would be coming into this quadrant over here. Negative x, positive y. It would be in quadrant 2. This side would have a negative 5 as an x, and this side would be a y as a 2. So what's the value of the third side? Well, that's a Pythagorean theorem here that we can perform. So we get negative 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. 29 equals c squared. So this hypotenuse must be radical 29. So we're getting a triangle with reference to this angle that would have an opposite side of 2, an adjacent side of negative 5, and a hypotenuse of radical 29. So let's put in all of this information to figure out our trig ratios then. So first, the sine is the opposite over the hypotenuse. So 2 over radical 29. Cosine is adjacent over hypotenuse. So negative 5 over rad 29. And tangent, opposite over adjacent, or 2 over negative 5. Since, though I line them up in this way, the other functions, the reciprocal trig functions, can be done by just performing a reciprocal on the originals. So the cosecant is the reciprocal of sine, meaning rad 29 over 2. Secant is the reciprocal of cosine, meaning we get a radical 29 over negative 5. And the reciprocal of the 2 over negative 5 would be a negative 5 over 2. So these answers should be acceptable in most intents, for most intents and purposes. You can rationalize problems that have radicals in the denominator, and usually I like to write my negative out in front, but I'm a little bit impacted for space here, so I'm just going to leave those ones as they are and see if I can fit them on maybe the next screen. So why don't you try one on your own here? Suppose that negative 3, negative 7 is on the terminal side of theta, and then figure out what these 6 trig functions are. These 6 trig values are going to give you. So assuming you paused it, gave it a shot on your own here, negative 3, negative 7 means we'd be moving left and down. So you'd have negative 3, negative 7. This triangle looks like it would be in quadrant 3 then. Okay, so mark that little angle right there. To find the hypotenuse of this triangle, I'm going to take negative 3 squared, which is 9. I'm going to add on negative 7 squared, which is 49. So I get a total of 58. And that means that the hypotenuse here would be square root of 58 by the Pythagorean theorem. So now over into inserting the trig values. Sine is opposite over hypotenuse, so negative 7 over rad 58. Cosine is adjacent over hypotenuse, that'd be a negative 3 over rad 58. And the tangent is the opposite over the adjacent, which would be negative 7 over negative 3. So I'm going to reduce that to 7/3, right? We don't need the negatives would cancel out. On the right hand side, for the reciprocal trig functions, we'll just take the reciprocal of all of these. So rad 58 over 7. I'm going to put my negative out in front now. Flip rad 58 over 3. Let's see if I can get my negative there. Yes, I can. And then the reciprocal of 7/3 is just 3/7.